bit different. Let's just make sure that I'm live. Okay, yeah. Okay. All right. So I figured I should have some kind of explicit goals um uh on where I think I'm gonna spend the next while. So I think I'm gonna take on I'll continue the machine learning papers as well as Rust. It seems to be a different way. It's still imperative with some functional elements, but it seems to be a bit smart, or maybe not smart. It's restrictive in terms of how you handle memory. So it's a new style of programming rather than paradigm. Um, like it's still imperative, but it's about memory management is the crux of Rust, or what why Rust is appealing, because it promises you that you have um, native speed, like it compiles down to machine language, and while it doesn't have GC, no garbage collection, no dynamic allocation. Well, uh, there is explicit memory management, but rather than C++, it's up to you to create and deallocate. Um, you have to use memory in certain ways, such that you would never have data races. Not if you use the language. If you use safe Rust. If you use unsafe Rust, you can of course undo all that. But if you use safe Rust, it promises that you will never have data races as long as you adhere to the memory ownership model. Um, and you have the compiler to help you with that. So your code will not compile if the compiler thinks that you have deviated from the given model for Rust. Okay. So aside from ML papers, of course, number one is Kanji. So there are two parts of this. This is Kanji, the actual getting to know the characters. So getting to know the characters itself and knowing what characters exist and their primitive meanings. Um, Whereas there's also the reading and vocabulary. It's rather than vocab plus reading. I figure I should. I am for this one. I am nearing around 40%. Like I'm closing to around 600 something kanji. Um, I'm expecting. So I Okay, in the book Remembered in Kanji, you after 27, you would have completed um 1100 something, I think 1100 something kanjis, which is half the Joyo 2200 kanjis. Okay. Yeah, after chapter 27, I am currently in chapter 23, starting chapter 23. So there's 24, 26, 20, oh shoot, 25, 26, 27. The problem is this guy is 140 characters. 49 actually. This guy, oh maybe not, 140, sorry. Yeah. This guy is I don't know, around 40 something. This guy is was it 90? I believe it's 99, and this guy is 60, and this guy is 70 some 73 or something. Yeah. So it will take me, I believe, 2 weeks to finish these. Um, yeah, I believe it should take me around 2 weeks to finish these if I uh do my best. Um, Now once I get the characters themselves down, oh, so this is only half the battle. But I'm expecting to ramp up. Um, because I would have known the I think I would have known I will have known um the majority of the primitives. Um so I will probably be able to ramp up. Um yeah. Vocabulary and reading, this is completely contingent on I'm familiar with the grammar. So grammar is, oh, at least the Genki 1, Genki 1, Genki 2. I have them both down, so I understand them. Maybe a little refreshing. Uh, I'm not going to go back to Genki. Um. So I know the grammar. So more more grammar for the sake of grammar is not going to be beneficial. It's more about how vocabulary is being used. Like even when you reach a level of grammar, it's more about uh, so once you reach a certain level of grammar, you will find that most of Japanese grammar is basically like relative clauses, clauses modifying a noun. So, for example, uh, uh, I bet it's cool. I bet it's okay. Okay. Uh, dai. Ah, daijo. I'm gonna write. Daijobu wake wake desu. Ah, ah, dai, um, jo, bu, wake desu. So this part is a whole phrase that modifies the so this is the I bit part. It's basically saying it is the case, so it is the case that it's daijoubu. So there is, if you want to say, if there is no way it's okay, no way it's okay, it would, you just need to make this negative. Wake janai desu. So you would put the ja nai desu. Oh, this is, yeah. Wake nai desu or wake janai desu. So yeah, most of the high level grammar is just modifiers on certain Japanese vocabulary. So basically, it's learning how to use the vocabulary that gets you going, and you will only get this down by seeing examples. Of course, they're not gonna be grammar rules that pin down every connotation that you will ever have. It's all gonna be by example. So yeah, right. So and of course, the biggest hurdle to reaching this step, because most of the written Japanese is going to be involved kanji, is getting down, being familiar with the kanji, not fully. I don't have to be able to read it and know the readings in order to. I have furigana, like I can enable furigana, but in order to have something to anchor the vocabulary meaning at. So I know that, for example, uh, this is saru. Saru is monkey, right? Um, but maybe something like this: monkey hunt, something like this, and this is like um, let's say. The practice of hunting monkeys. Okay, whatever it is. So now I can hook the vocabulary word itself, and this will have a meaning. Consent, for example. I'm not sure what this one, if this word exactly exists or not. Consent. So now I have a consent, and I know the primitive meaning, or something that to hook it up with, and yeah. So but at least I'll be familiar with the characters themselves. The reading is probably not is fine, the reading, because every character can have multiple readings, so I'm not gonna yeah, it's only gonna be with it will depend on the actual vocabulary itself. And in order to get to know the vocabulary, I will have to know example sentences. You never learn a language by reading the dictionary and knowing grammar rules and then substitute with templates. No, that doesn't work. You have to see the words in action in order to see how it's used, certain connotations, colloquials, what is natural, what sounds natural, what doesn't sound natural, and so forth. I'm not going to invent my own Japanese by using vocabulary that I learned separately and applying it into sentences. No, I'm going to see. I'm going to have to see. I'm going to have to see a lot of examples, and the examples will have to guide me. Like, this is how I learned English. Sure, we spent lots of time in school drilling down grammar, drilling down vocabulary, but aside from actually consuming the language itself and getting getting exposed to the language itself, nothing really can teach you a language. Um, yeah, that's uh, that's the on the kanji part side of things. Uh, why is it not deleting? Edit preferences. No, it's not deleting. Okay. Preferences. System. Okay. Sure. Whatever. Sure. Let's clean the area. Okay. When it comes to ML papers, I'm gonna be focusing on four things. Maybe these close together. Cheap convolution, transformer architectures, um, efficient training, augmentation comes in here as well. Generative modeling, representation learning. So these two are quite entangled both together because generative modeling usually uncovers latent variables, and these latent variables act as a representation in some space, and it so here a semantic it's the semantics of the uncovered representations that I'm going to examine. If I can achieve like something like this entanglement or not. There's a lot of work done in this field, and yeah, I did efficient net before. There's also lambda nets also. So for transformers, there's performers. For efficient training, this is differential augmentation. It's gonna be 1. For generative, so this is smooth adversarial training. There's also better VAE. Especially I want something like a pushback prior. Okay, so all of these are on the burner. And afterwards, so there's a lot of mathematics before Rust. Let's talk about other mathematics that I want to focus on, to learn. Um, so there's a lot of math I want to solidify my knowledge in. Um, let's see. So, uh, measure theory, abstract algebra, um, category theory, type theory, uh, algebraic topology, algebraic and differential topology, and differential geometry. I'm not sure where to start. Um, I know that these are related. Um, because I remember when I started to study to watch lectures of measure theory, it would go on Borel sets, sigma algebra, etc., etc. So I think I might need to start here if I want to reach measure theory. So why interested in this? I'm interested in these in measure theory, especially because of optimal transport. Um, um, and I am interested in category theory and type theory for functional programming. And I am interested in algebraic, differential topology and differential geometry for neural networks. Neural networks. It's probably even in differential forms. Differential forms. Yeah. I might start this Bartosz's course. This Norman Wildberger, and these I might go with James Cook. Okay. Am I interested in any other math related topic? Well, maybe no, not really. So, since calculus is to really be a big part of this, it's gonna be real analysis here, real Aliases. Yeah. I might have to also go back to this. So yeah, that's a lot. Yeah, that's a lot. But it's probably not too like I can in a year I can get good in all of these probably if I do my best. On the programming side, there is Rust, Haskell, PureScript, um, Rust, Haskell, PureScript, Scala, Scala 3, and ZIO. Yeah, so these what I'm gonna be interested in mostly. Uh, and it's gonna draw a lot heavily on functional programming. So I'm gonna try to stick to functional programming paradigms as much as possible. Apparently, Rust has a great deal of functional support. So, uh, and it's a bit practical as well because so there's no uh there is no garbage collector, and memory is guaranteed to be data race free if you adhere to the what the compiler says. So there's a lot to gain and not much to lose if we do it properly. Somebody's watching. Let's see. Ooh. Lurks. Okay. Okay. All right. So let's get started with Rust the language. Okay, Rust, a language empowering everyone to build reliable and efficient software. Why Rust? Performance. Rust is blazingly fast and memory efficient. With no runtime or garbage collector, it can power performance critical devices, run on embedded devices, and easily integrate with other languages. Reliability. Rust's rich type system and ownership model guarantee memory safety and thread safety, enabling you to eliminate many classes of bugs at compile time. Productivity, yeah. So we said I'm gonna read the book. Yeah. Let's read the book. Read the book. There's the rustling's course. How far does this rustling, greetings and welcome to lessons. This project contains small exercises to get you used to reading and writing Rust code. This includes reading responding to compiler messages. Looking for the old web-based version of ruststrings? Try it here. The book, most comprehensive resource for learning Rust, but a bit theoretical at sometimes. You'll be using this along with rustlings. Rust by example. Learn Rust by solving little exercises. It's almost like rustlings, but online. Okay. So this covers hello world, primitives, custom types, variable bindings, types, conversions, expressions, flow of control, functions, modules, crates, cargo, attributes, generics, scoping rules, traits, macros, error handling, standard library types, standard miscellaneous, testing, unsafe, compatibility, documentation, and benchmarking. Alright, Rust is a modern, okay. It accomplishes these goals by being memory safe without using garbage collection. Rust, by example, is a collection of runnable examples that illustrate various Rust concepts and standard libraries. To get even more out of these examples, don't forget to install Rust locally and check out the official documentations. Additionally, for the curious, you can check out the source code for this site. Not really. Okay, getting started. You need to have Rust. I have Rust. I'm gonna have to update to the new version. Rust up. Update. Let's see. So what's new? What's in the new version? Easier linking in rustdoc. Rustdoc, the library documentation tool included in the Rust distribution, lets you write documentation in Markdown. This makes it very easy to use, but also has some pain points. Let's say you're writing some documentation for some Rust code that looks like this: pub mod foo, pub struct foo, pub mod bar, pub struct bar. We have two modules with each a struct inside. Imagine we wanted to use these two structs together. We may want to note this in documentation, so we would write docs like this. Some docs for foo, you may want to use foo with bar. Some docs for bar, you may want to use bar with foo. That's all well and good, but it would be really nice if we could link to other types. That would make it easier for the users out of the library to navigate between items in our docs. The problem here is that Markdown doesn't know anything about Rust and the URLs that Rust doc generates. So what Rust programmers have had to do is write these links out manually. Okay. Note that we've also had to use relative links so that this works offline. Not only this process tedious and error prone, but also just wrong in places. If we put pub use bar in our crate root, that would re-export bar in our root, and now our links are wrong. But if we fix them, then in this release, you can use some code, some syntax to let it know you're trying to link type, and it will generate the URLs for you. Okay, I'm not sure what this. We've also had to use relative links so that it works offline. Sure. Not only is this process tedious and error prone, but it's also just wrong in places. If we put pub use bar in our create root, that would re-export bar in our root, sure. So the bar is available directly on the root. Now our links are wrong, but if we fix them, then they end up being wrong when we navigate to the bar that lives inside the module. You can't actually write these links by hand and have them all be accurate. In this release, you can use some syntax to let rustdoc know that you're trying to link to a type. Will generate, okay, here's the link and here is the location. The first example will show that same text as before, but generate a proper link to the bar type. The second link, foo, yeah. There are a bunch of options you can use here. Please linking item by name section in the Rust. There is also a post on inside Rust. Okay. Adding search aliases. You can specify doc alias on items to add search aliases when searching through Rust doc UI. This is a smaller change, but it's useful. Okay. With this annotation, if we search bar, foo will come up as part of. Okay. An interesting use case for aliases is FFI wrapper creates, where each Rust function could be alias to a C function it wraps. Existing users of the underlying C library would be able to easily search the right Rust functions. Okay. Library changes. The most significant API change is kind of a mouthful. TN try from vector. T is now stable. What does this mean? Well, you can use this to try and turn a vector into an array of a given length. Use std convert try into vector 123 v1 dot try into accept wrong length into 3. Try into wrong length. This will panic since we have wrong length. In the last release, we talked about standard library being able to use const generics. This is a good example of the kinds of API that we can add with these sort of features. Expect to hear more about stabilization of const generics soon. Additionally, we have 5 new APIs were stabilized in this release: as pointer range, as mod per pointer range, make contiguous, pending, ready. The following previously stable APIs have been made const. What is Clippy? Contribute, okay. Option is some, is none, as ref, as okay, is error, as ref, reverse, then. Ordering reverse and then. Const. Const generics. Oh, so you can have unsafe module directly. Unsafe one, okay. Stabilized. IO write is now implemented for child stdin, sync, std out, and std error. Okay, so this was updated to 148. This was updated to 150. Okay, cool. I'm not sure what closures will now warn when not used. Okay, this is 47. Not sure what they mean by stabilization. Let's see, make contiguous. Stable means with the same order, right? Like stable search.